exponents. And if they're exponents, they are going to follow the exponential rules. Now, on the previous 4.2, we saw that we had to do a lot of thought process to get to what is log base 2 of 8. And I still want you to be able to do that. But what happens when we don't have something that we can raise to a nice integer value or fractional value or negative value and still get to the right answer? So for example, log base 5 of 80. So our thought process says 5 to what power would give me 80? Well, we know 5 to the first is 5, 5 squared is 25, and 5 cubed is 125. So this power is in between 2 and 3. But we don't know what it is because it's not a nice integer value. But we do know it's going to be in between 2 and 3, again because 5 squared is 25 and 5 cubed is 125, so 80 lands right in between. So we have this thing called change of base, and you definitely want to make sure you have memorized change of base. Very important that we use it over and over and over again. And what's great about change of base is let a, b, and x be positive real numbers such that a doesn't equal 0 and b doesn't equal 0. Then the log base a of x can be converted to different base. We can convert it to base b, which doesn't really help, but we can convert to base 10 or base e. Why we would like to convert it to base 10 or base e is because base 10 is in our calculator. There's log, so that's base 10. And base e is in our calculator because we have the natural log key. So the great thing about changing it into a base we can use is now we can use our calculator. So when we ask what is log base 5 of 80, we're going to change it into base 10. So that means take the log of the argument over the log of the base. But do you see what our base is now? Our base is base 10. So we do the log of the argument divided by the log of the base. And it should be in between 2 and 3. So log of 80 divided by log of 5. And we see we get 2.7. So we know we were in between. And it does say round to 3 decimal places. So approximately 2.723. Now, we don't have to just change it into log base e, log base 10, we could also change it into log base e. You can use whichever base you want. So let's go ahead on number 2, let's do log base e. So we could say log of 15 divided by log of 4. That would change it into base 10. Or we could say the natural log of 15 divided by the natural log of 4. That changes it into base e. You get the same answer because we're just changing into a different base. So the natural log of 15 divided by the natural log of 4 would give me approximately 1.953. If we do the log of 15 divided by the log of 4, we're still going to get the same answer. We're just changing it into a different base that we can use our calculator with. So log base 4 of 15 is approximately 1.953. I'll let you do the last one on your own, and it's going to be approximately 4.192. So hugely important that now we can go ahead and think about not having to do our thought process all the time. So back to here on page 8, if we said log base 5 of 125, you could just say that is the log of 125 divided by log of 5. Make sure you put the base on bottom and the argument on top. And that would give me, you know, the reason why logs turn out to be the way they do is because we're just looking for that nice little exponent. But you can certainly use change of base. There's also another way to type this into your calculator, but I like to show everyone how to do change of base. All right, so now let's talk about properties of logs. Let a be a positive number such that a does not equal u and v are positive real numbers. The following properties are true. If you're multiplying inside a log, you break it up into addition. So think back on our rules of exponents. When we're multiplying, we add exponents. So we're going to add the first exponent plus the second exponent. When we're dividing, think back of our rules for exponents. When we're dividing, we subtract. So the log of the argument on top minus the log of the argument on bottom. That's your quotient rule. We're subtracting when we divide. And our third one is when we raise a power to a power. When we raise to a power, we multiply. So this is kind of the only different one is your power comes down in front and makes it into multiplication. So with the product rule, we add our powers. With the quotient rule, we subtract our powers. And with the power rule, we multiply power times power. So some of the mistakes that I see students make is when they're multiplying a log inside, they want to just do multiplication. No, multiplication breaks up into addition. Division does not break up into division. Division breaks up into subtraction. And you cannot expand pluses or minuses for that matter. So what are the three things we can expand upon? We can expand upon multiplication, division, and powers. So that's what I want you to ask yourself when you're going through these problems. What do you have out of those three things? So this says use properties to expand the expression as a sum, difference, or constant multiple of logs. So really all you're going to want to know is it says use properties to expand. So what are the things we can expand again? We can expand multiplication, and that expands into addition. We can expand division, that would go into subtraction. And if we have a power to power rule, we can make that into multiplication. I don't really like how I wrote that. So we'll say power to power rule. All right, so let's look at number 1. Going through the list, do we have multiplication? We do have multiplication because this is 3 times x. So we're going to break this up into multiplication, breaks up into addition. So nothing changes, the base still stays the 3, so log base 3 of 3 plus log base 3 of x. Now, we don't have any powers and we don't have any division, but the problem is we're not done. Why are we not done? Because we should know what log base 3 of 3 is. And we say 3 to what power gives me 3? Our answer is just 1. So 1 plus log base 3 of x. So I always tell my students, if you're left with just a number, make sure that you can possibly evaluate what that is. Now, what if we wanted to use that change of base that we learned? Well, that would just be log of 3 divided by log of 3. And if you press enter, I'm not going to be very happy because you should know that log 3 divided by log 3 is just 1, right? So you could do change of base, but hopefully we still do our thought process. So on number 2, we have log base 2 of x divided by 4. So we have division. When we have division, division breaks up into subtraction. So log base 2 of x minus log base 2 of 4. This cannot be simplified anymore because we don't have any multiplication left, division, nor powers. But this is back into just numbers, so we should think to ourselves, 2 to what power gives me 4? And the answer would be 2, because 2 squared is 4. So again, we could take our calculator and do change of base, or just hopefully do our thought process. And then lastly, on number 3, we have log base 5 of x squared. So we ask ourselves, do we have multiplication? No. Do we have division? No. But do we have a power? Yes. So that power goes straight down in front of the log and becomes multiplication. So log base 5 of x stays as is, but the 2 comes down in front. So 2 times log base 5 of x. All right, so let's look at number 4. Well, do we have multiplication? Nope, we have addition. No division. Do we have a power? It's a little tricky. We do have a power, but it's not written. Remember in the previous sections we said what the square root looks like as a power. So this is a natural log of x plus 3 raised to the 1/2. So square roots, remember your index is a 2, so it can be rewritten as a 1/2 power. Cubed root would be rewritten as a 1/3 power, and so forth. So now we do have a power, so the power needs to go down in front. So 1/2 natural log of x plus 3. You cannot expand addition or subtraction. You can only expand multiplication, division, and powers. Now let's look at number 5. Do we have multiplication? Yes. Do we have division? Yes. Do we have powers? Yes. We got them all. Well, since everything is being raised to its own power, leave that to the last. So we're going to start off by expanding multiplication. And multiplication expands into addition. So natural log of x plus natural log of y squared. And then division expands into subtraction. So natural log of z to the 4th. When you expand, you want to write multiple logs. So everything that you expand has to have its own log. And this was an ln, so ln has base e, so we have base e for all of these. This one's done. The first term is just ln of x. Now what should happen next? The power goes down in front. So plus 2 natural log of y. And the 4 goes down in front. Minus 4 natural log z. We've gotten rid of multiplication, division, and powers, and there's no, so we are done. All right, so looking at number 6, log base 9 of 9 divided by x. We have division. So division would change into subtraction. So log base 9 of 9 minus log base 9 of x. Remember, whenever you have just numbers left, see if you can evaluate this. So we ask ourselves, 9 to what power gives me 9? The answer is 1. So 1 minus log base 9 of x. So on number 7, we have the natural log of the 7th root of x. So just like the square root was 1 over 2, the 7th root would be 1 over 7. So bring down the power out in front, and we have 1/7 natural log of x. So on number 8, we have the natural log of the square root of e times x. Well, we do have a power, so we have natural log of e to the x all raised to the 1/2 power. So there's a couple different ways to do this. One way is if you bring the power down in front, make sure you distribute it because everything was raised to the 1/2 power. Or separate each one, natural log of e to the 1/2 plus natural log of x to the 1/2. Multiplication expanded into addition, and each of those are raised to the 1/2 power, so each of them are going to have the 1/2 still there. Then what happens is the 1/2s go down in front because powers go down to make multiplication. So 1/2 natural log e plus 1/2 natural log x. Now, you might not realize, but natural log of e was one of those properties from 4.2. The natural log of e is just 1. Why? Because base e 1 times 1/2 is just 1/2. So we have 1/2 plus 1/2 natural log x. Let me write that again. So we have 1/2 plus 1/2 natural log of x. Again, natural log of e, they cancel each other out, so you're just left with a 1, and 1 times 1/2 is 1/2. All right, let's look at number 9. Number 9, again, we have a radical, and radicals can be rewritten as fractional exponents. And all of these are going to have a power of 1/5 raised to each one. So we have log base 2 of x to the 1/5, y to the 4/5 over 16 to the 1/5. Why is that? Because this is x, y to the 4th over 16, all raised to the 1/5 power. So then the 1/5 gets distributed to every power. 1/5 times 1 is 1/5, 1/5 times 4 is 4/5, and 1/5 times 1 is 1/5. And now we're going to expand it. We have multiplication, we have division, and then we'll deal with powers. So we're going to have log base 2 of x to the 1/5 plus log base 2 of y to the 4/5 minus log base 2 of 16 to the 1/5. Now powers can go down in front. So the 1/5 goes down, the 4/5 go down, and the 1/5 goes down. So 1/5 log base 2 of x plus 4/5 log base 2 of y minus 1/5 log base 2 of 16. This one's done because we have a variable x. This one's done because the argument is a variable y. This one's not done because we should know what log base 2 of 16 is. So 2 to what power gives me 16? 4. Again, if you don't remember that, you could use your calculator and do the change of base, which would be the log of the argument divided by the log of the base. And we end up with 4. And 4 times 1/5 is 4/5. So I'm going to come back up here to write that final answer so we don't get too far down here. So we have 1/5 log base 2 of x plus 4/5 log base 2 of y minus, and this just turned out to be a 4, so 4 times 1/5 would be 4/5. And that would be the answer to number 9. So that might be the most challenging. You have all kinds of powers and fractional powers and so forth, but I would definitely rework that one again. There's different ways to get to that answer, but that's probably the way I would do it. So now we're obviously in math, when we go one direction, we always want to go the other. And since we were expanding, now we want to condense. So what can we condense? We can condense subtraction, we can condense addition, and we can make powers jump back up. So when logs are separated, we can put them back together by condensing them into one log. So remember, when you see the word condense, you want to write one log and one log only. But when you see the words expand, you're going to want to write multiple logs. So expanding, write multiple logs, but condensing, we want one log and one log only. So see how we have two logs? We want to write log only and then condense the arguments. Now what does log have a base of right now? This is base 10, so we're going to put it together as one log. And subtraction condenses back into division. And that's it. So what about number 2? Well, we have log base 2 of x and log base 2, so we know we are going to condense the logs so they have the same base. So log base 2 of, and then we have to figure out how we're going to condense. Well, addition condenses back into multiplication. So it's going to be x. Oh, but be careful here. We have a power that should also jump back up. So the 4 is going to jump back up before we condense. So it's going to be x times x plus 1 raised to the 4th. So always take care of those powers first, make them jump back up and become a power, and then go ahead and do your rest of your condensing. So on number 3, we have lots of powers that need to jump back up. This is a power, so it jumps back up, becomes x to the 5th. This one jumps back up, and the 3 jumps back up. So we're going to have the natural log of x to the 5th plus the natural log of y to the 7th minus the natural log of z to the 3rd. Now that our powers have jumped back up, we're going to condense into one log and one log only. We have addition, which condenses into multiplication, and then we have division because of the subtraction, and we get z to the 3rd. So my final answer is just the natural log of x to the 5th, y to the 7th, over z to the 3rd. Now, number 4, we have a power on the outside, so that's going to be distributed to every power back up when it moves back up because of the brackets. So the first thing we want to do is move that power back up. Or we can do what's inside the brackets and then put the 2 up. Well, let's do it that way. Keep the 2 out in front. Addition turns into multiplication, and subtraction turns into division. Since we're condensing, we want one log and one log only. So x plus 1 times x minus 1 all over x. Addition turned back into multiplication, subtraction turned into division, but we still have that 2 that needs to jump back up. Because it was in a bracket, that 2 has to go to every single one of them. So it'd be x plus 1 to the 2nd, x minus 1 to the 2nd, all over x to the 2nd. Because when that power jumps back up, it has to be distributed to everything on the inside.